In flies, red eyes, big R, are dominant to brown eyes, little r, and brown bodies, big B, are dominant to yellow bodies, little b. A fly with genotype big R, big B, little b, is mated with a fly with genotype little r, big B, little b. What percentage of the offspring created by this mating will have genotype big R, big B, big B? So first I want to make sure I understand the genotypes I'm using, and they've made it pretty clear. So one is big R, big B, little b, and the other is little r, big B, little b. So now I can make my Punnett squares. Since I'm talking about two traits, I need to make two Punnett squares. My first Punnett square will be about eye color. And so I have one that's homozygous dominant, big R, and one that's homozygous recessive, little r. So now I can fill it in. My other Punnett square will be about body color. So I have one that's heterozygous for body color, and the other is also heterozygous for body color. And so now I can fill that in. And let's look at our question. It wants to know what percentage of the offspring will have genotype big R, big B, big B. So heterozygous for eye color and homozygous dominant for body color. Well, there is actually 100% chance that the offspring will have a heterozygous genotype for eye color, because all of the offspring will have that. And looking at body color, I can see that there is a 25% chance that they will be homozygous dominant for body color. So whenever I have two percentages from my Punnett squares in a dihybrid cross, I always multiply them together. So you would actually put in 1 times 0.25, which is 0.25. Anytime you multiply by 100%, it's like you're multiplying times 1. So my answer is just 25% chance. So there is a 25% chance that the offspring will have genotype big R, big B, big B.